Hello everyone. Today let's solve the problem number 647 palindromic substrings, right? So let's see what the question states here. Just give me a second. Uh yeah. So we have been given a string S. You can clearly see here string S, which consists of the string ABC, right? The letters ABC within the string. So we have to return the number of palindromic substrings in it, right? So number of the palindromic substrings in it. Palindrome. So when we read backward and the forward, it has to be, the letters has to be same, or the word has to be same. Whatever we are considering, it has to be same from the forward and backward, right? So a string is a palindrome when it reads the same backward and forward. This is fine. A substring is a contiguous sequence of characters within the strings. A substring is the this one contiguous sequence of the characters within the string, right? Just remember this one. So this is very important because substring is only the contiguous sequence of characters, right? Not the non-contiguous sequence of characters. So contiguous in the sense continuous, so we have to consider continually, right? So a substring is a contiguous sequence of the characters within the string, right? So this is fine, man. Now let's move on with the example one. We have string s equals abc. The output that we have got here is 3. So 3 palindromic substrings we are going with here. One is A, another one is B, another one is C, right? So this one, this is A is a palindrome, B is a palindrome, and C is a palindrome as well. So let's move on with the example 2 here. We have triple A. Triple A, we have 6. We have to go with the count. We have to return the count. A, B, C we have, but the count, so this is one palindrome, this is one palindrome, this is one palindrome. So count is 3. We have to return 3. So here we have triple A. So this 6 can be found. So a single A, these 3 A's are different, right? So we got 3. Then we can just go with double A, right? So this A we can go with, and the second one, third A also we can go with, second and the third one. So 5 total. Then finally this triple A, this is also palindrome. When we read this one from the forward and the backward, this remains the same. So this is also palindrome. 5 plus 1 is 6. Total, we have this one. See, they have mentioned in the explanation, same thing. A, double A twice, and triple A once. The output that we got here is 6, right? So which is absolutely correct here. So the output they have shown here is, the output that we have got here is 6, right? Also they have shown is 6, which is absolutely correct. Now let's do one thing. Let's quickly discuss the approach followed by the complexities, and then let's write the code, right? So first thing I want to tell you is we will be going with a DP, dynamic programming, basically 1D DP. So we'll be making use of to solve this particular problem, right? So let's move on with the first step here. Let's consider the same first example for the approach, right? So that we'll easily understand the approach. So we'll be making use of the 1D DP array, nothing but let's consider DP of J. Let's go with the same within the code as well. Then if I'm considering here, let's go with the same thing within the code. We use the DP 1D DP array, DP of J, that will mean substring, this one, substring from I to J. Substring from I to J is a palindrome. Substring from I to J is a palindrome, right? So the second step here would be, this is the first step basically. What would be the second step here? The second step here would be, we will be iterating the starting index I from right to left. We will be this one, iterating the starting index I from right to left, from right to left, right? So n minus 1 down to 0, and for each I we will be iterating end index from j to I for this one basically, and for each I, right? So we will be iterating index from this one, iterating end index j from I, basically j from I, right, to n minus 1 basically, right? So this one to L, this one, sorry, what do we call? How do I say that? Start, uh, we are iterating the starting index I from the right to left, right? Right to left here. And here, this one, for each I, we are iterating end index j from I just to this one, n minus 1 to n minus 1. So this is fine now, hopefully. Yeah. Now, the third step, what we will be doing here, for each pair I comma j, right? So we have the pair I comma j. So we'll be going with the two loops, right? So here, for each pair I comma j, we will set dp of j here. We will set dp of j to the s of I equals s of j, and j minus I less than 2, or dp of j minus 1. So this one you will get to know when we write the code. So just listen to this. Dp of j equals s of I equals s of j, right? String of s of I the value that is equivalent to the S of J double equals, right? So we are comparing if the values are same, and J minus I less than 2 or dp of J minus 1. Here dp of J minus 1 still holds the previous this one row's value for the substring S of I plus 1 to J minus 1. Just remember this one, right? Finally, the fourth step here would be we will be going with this one. We have to return true if d of J becomes true, basically, right? So we if the dp of J, so let me write this one. If dp of J, this one becomes true, if the dp of J becomes true, this one, then we will be incrementing count. Actually, we'll be incrementing count. So I'll just go with, will be incrementing count. So these are the steps that we'll be following. Basically, this is the approach that we will be going with, basically along with the dp, right? So let's try to implement the same thing for the example one so that we understand this one even better, right? So string, we have abc here. This is very simple example. This is the best example to consider, actually, right? This is not so lengthy, not completely this one. We don't have the single letter at all, right? Not small as well. So first what we will do, I we have two, this one, J also we have two. So indexing starts from 0 here, 0, 1, 2, right? So I equals to 2, J equals to 2 initially, right? So J equals to 2, we have C at the index 2, right? The last one. Indexing starts from the 0, right? So we will compare C is equivalent to C or not accordingly with the approach that we discussed. And yes, C is equivalent to the C. So which is of the length 1. So this one here, dp of 2 is true, right? So dp of 2 is true, and the count we will be incrementing from 0 to 1. Initially we'll be setting the count to 1. So dp of this one is true, and so count equals 1 here. Count equals 1, right? This is fine. Now we have I equals 1 and j equals 1. I equals 1 and j equals 1. Right. So now we will be going with a b. Actually, we will be checking whether b is equivalent to b, because at the first index we are going with I1 and J1, right? At the first index, see here we have b. Second index we considered, we had c. Now we are considering first index, right? So this is for the second index, this is for the first index b. So yeah, now dp of 1 is also true because b is equivalent to the b, right? So this is true, and count we will increment from 1 to 2. Actually, count we will increment from 1 to 2. And also we have dp of 1 is true, this is fine. Count equals 2, everything is fine. But here b is not equivalent to the c, right? Sorry, now I got confused here. This dp of 1 becomes to true, basically this is fine. Now b is not equal to c here. B is not equal to C, right? B is not equal to C because count has become 2 here, right? So J is equivalent to 2. J becomes 2 here, and B is not equal to C. And now dp of 2 will be set to false. This one also, this is also very important. dp of 2 will set this one to the false. So finally, we are left with only one step. When index this one, when I equals 0 and j equals 0, sorry. Its first step, as usual, we'll check this one. We have the letter A. So we'll check with A, right? So this is fine. So now dp of 0 will be set to true. dp of 0 will be true, right? So this is fine. And now we will increment the count from 2 to 3, right? 2 to 3. So just remember this one. We have incremented the count from 2 to 3, right? So here j equals 1 now. A is not equal to B. So now j becomes 1 and A is not equal to 3 here. A is not equal to 3. Sorry, A is not equal to B, man. Sorry, not 3. A is not equal to B here. And dp of 1 will be set to false. dp of 1, dp of 2 previously we had set to false. dp of 1 we are setting this one to the false, right? And also when j equals to 2, j equals to 2, we know that A is not equal to C, right? A is not equal to C, right? So the values, A, the count of A, this is not equal to C, right? A and C we have, not A and A. So this is not equal to C. So dp of 2 we'll set this one to false as well. This is also false, right? So now a DP of 2 and DP of 1 is set to false, and the final count that we have here is 3. Sorry, this one. The final count we have here is 3. So this 3 we will return this one as the output. The output that we got here is 3, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the this one complexities, and the final count that we got here is 3, which holds this one A, B as well as the C, this one as the palindrome basically, right? So this is 3 itself. Now as I've said, let's move on with the complexities part, man. So what would be the time complexity here? The time complexity would be pick of n square. So we are going with a I and j, right? Two for loops basically. So because this one n square, because we will be visiting each pair I comma j with a I less than or equal to j once. So this one you will understand when we write the code clearly. This is fine. So what would be the space complexity? Space complexity would lead to big of n as well, because a single Boolean array dp of the length n we will be considering. We'll be considering a single Boolean array dp of the length n. So this will be the space complexity. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n square and big of n respectively, right? Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Just give me a second here. Yeah. Now let's start writing the code. First step here would be we'll be making use of the length of the input string many times. So let me assign that one to the variable n here. So this is fine. To go with the parenthesis. Yep. Now we know that dp of j will represent whether substring s of I to j is palindrome for the current I iteration or not. We know this one from the approach basically. Let's go with the Boolean. So let's this one, what do we call? Initialize dp to new Boolean of this one, what do we call? N. So that is the reason I said the last sentence, that dp of j will represent whether substring I to j is a palindrome for the current I iteration or not. That is the reason we have considered the type Boolean here, right? So that is the reason I said that long sentence. So now we need the result counter. We have to return this one itself in uh, the number of palindrome that we have found, right? For that one, to store that one, we need the result counter for the palindromic substring. So I'll just go with here int count equals initially 0. Right now, let's move on with the iteration part. Let's iterate the start this one index I from the right to left. So dp of j minus 1 refers to the previous row value s of I plus 1. Right. Also for each start I, let's iterate end index j from I to n minus 1. Two iterations I and j in simple terms. Right. So this one I'll just go with int I equals n minus 1. This is fine. I greater than or equal to 0. I minus minus. So this is fine. So the second for loop here is int uh, j equals 1, j less than n, j plus plus, right? So within the for loop, what we'll be doing? So let's go with the characters at both ends that must match basically, right? Let me go with the simple if condition here. S dot char at, so this is caret of I equivalent to s dot char at. So this is fine. J, this is fine. Now within the if condition, if length is less than or equal to 2, then it's a palindrome when the ends match basically. Otherwise, we have to check dp of j minus 1, which currently stores whether this one s of I plus 1 to j minus 1 was palindrome, right? Let's write the simple if condition for that. We know this one from the approach, man. Let's write this one very quickly. So this one will be if j minus 1 less than 2 or dp of j minus 1, uh, then let me set the dp of j to true. I hope I have written correct one. Right. So else, I hope this is correct. Let's hope for the best. So else we have to go with this one s of I to j. If it is not a palindrome, the because inner substring isn't a palindrome. So this one, I can just set this one in this way. dp of j equals false, right? So this is fine. Let's go with one more else here. Else, if the ends don't match, then it is not a palindrome. We know that. So this one, we can directly set the dp of j to false. Simple. The final step would be, I have missed something somewhere. Hmm, did I? No. Okay. Yeah, let me come out of this one entirely. Now let's write the simple if condition. If s of I to j is a palindrome, then we have to increment the count as well. So this is very important, right? So we went from count 1 to count 2 to count 3, right? So that's what we will be doing here as well. If of dp of j, then let me go with count plus plus. So this is fine. Yep. Let's do one thing. The final answer is we have to go with the total palindromic substrings, right? So I'll just go with return count. This is fine, man. Let me format the code once and let me hit the run button. We are getting the wrong answer. ABC, we are getting the output 0. What mistake I have done here? So we are going with the n minus 1. Did I make anything? Give anything wrong in the for loop? N minus 1, this is fine. I great. We are going with the reverse iteration greater than or equal to 0 is fine. Yeah, this is fine. So yeah, this one has to be I. I thought so. This is not 1 actually. This is I. J less than n, J plus plus. Yeah, this is fine, man. Let me this one hit the run button again. Now we have to get the correct output. Yeah, the sample test cases are getting passed. So let me hit the submit button quickly. Now this has to work. Wrong answer again. I just give me a second here. So I have done the same mistake, I believe, here as well. See, in the line number 10, j minus 1 I have went. So here this has to be j minus I. So this one, I instead of I have typed 1 in the hurry. So this is fine. Let me hit the submit button directly. So now this has to work. Let's see. Still we have the same thing. Okay, do any mistake here. 1 second. So this one has to be j minus 1, I believe. Yeah, j minus I less than 2 or dp of j minus 1. This is fine. So let's do one thing. Let's go with the reverse iteration one for this one for the j as well. Let's check whether this works. The code actually, I feel the code is correct. Let's check with the reverse iteration. I'll just go with j n minus 1 here. Greater than or equal to I we have to consider. So let me decrement this one. So now this has to work. I don't know. Apart from this one, what changes I have to make? I think this is, yeah. Now this is working. Thank God. Yep. This is fine. Now this works absolutely correct, man. Yep. So whatever, this was the wrong thing basically. We have to go from the right to left or the reverse iteration for the J as well. So that is the reason we were getting the error, right? Also some typos. In case of j minus I had given j minus 1 everywhere, right? So that was the wrong thing. Now, whatever the code that we have written works absolutely correct for all the test cases, right? So, yep. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.